Good afternoon. Only two people came? Darshini and Ram Prasad. Let's wait, huh? Let's wait for other people to join. About 2 minutes we'll wait, right? Then OP. What OP? Overpowered? This is the term used in gaming and all, right? OP. Akshita, Anita have joined, okay? So many less people are there today. Chalo. So let's start. People will join slowly. How are you people? Everything is going good? Just quickly tell me if everything is visible and I'm audible or not. Yeah, tell me quickly. Okay, thanks for telling. Chalo. So in yesterday's class, we have done क्या किया था अपन ने? What we have done? We have done some questions. We have done work, and we have done conservative, non-conservative, kinetic, and potential energy, right? In potential energy, we have seen gravitational potential, spring potential, right? And I've given you this homework. So have you done this homework? Tell me the answer. इसका आंसर बताओ. Have you done the homework? Just tell me yes or no. If you have done, give me a quick tick. Not done, cross. From emoticons, you can select. Kuldeep, Darshini, Anita, Akshita. Have you done this question? Not responding. What happened? Okay, Akshita. No problem. चलो ठीक है. I think you have not done the question. We'll do in the class. Okay. Listen. Pay attention. Pay attention. Okay. People will join slowly. Don't worry about that. Okay. So it is telling a 5 kilogram ball when falls through a height of 20 meters. Okay. So there is a 5 kilogram ball, right? And here is the ground. So the distance of this ball from the ground is 20 meters. Okay, this is 20 meters, right? Acquires a speed of 10 meters per second. So when this ball falls means somebody was holding this ball, okay, and he just removed that hand and it started to fall under gravity. So when it fall, it is telling it acquires a speed of 10 meters per second. So when this ball reached here at the ground, it is having a speed of 10 meters per, sorry, 10 meters per second. Okay. That is the thing. So it is asking find the work done by air resistance. Let me give you a feeling of this question. If there was no air, agar koi air nahi hota, if there was no air, this ball has fall by 20 meters, right? And how much will be the speed? Let us find. So initial speed is 0 because it is starting to fall. Final speed is, let's say, V, final speed. And displacement is 20. So what and acceleration is G, 9.8, or approximately we can take 10 meter per second square. So what quantities we have? We have U, we have V, we have to find V, we have S, and we have A. So which equation I can use to find the final velocity if there was no air? अगर air नहीं होता तो कौन सा equation use करते? First, V equals to U plus AT. Time is not there. We will not use first. Second, S equals to UT plus half AT square. Time is not there. We will not use second. Third, V square is equal to U square plus 2AS. These all quantities are there. So I'll use this equation. Third equation of motion, where V is final velocity, U is initial velocity, A is acceleration, S is displacement. I hope you know these things. Huh? We have studied in kinematics, or you have studied in kinematics. So V square is equal to initial velocity is 0 plus 2 into 10 into 20. That is 400. That means V will be under root of 400 because V square was 400. So V will be 20 meters per second. That means if there was no air, this ball has acquired a speed of 20 meters per second, but it has 10 meters per second. That means somebody was there to push this ball upside. Okay. Somebody was there to push this ball upside. Okay. That's why its speed has only increased to 10 meters per second. Okay. Now, here the concept that we are going to use is called energy conservation. Okay. So at some height, 20 meters, which type of energy will it have? It is stopped. Will it have potential or will it have kinetic? Initial and initial. Tell me in the chat, इसके पास कौन सा energy होगा at some height 20 meters? Potential or kinetic or both? Yes, I'm waiting for your answers. Good afternoon, Rushikesh. Good afternoon, Samsung Smart Lab. It is stopped here. Okay. Velocity initial is 0 meters per second. We have studied what is potential, what is kinetic. when a body is moving, then it will have kinetic. When a body is at rest, it may have potential if if it is at some height from the earth's surface. Okay, so good afternoon Sangam, good afternoon Sukuru, Tisukuru. Kinetics, no. See, it will have some potential energy that is gravitational potential energy, that is mgh. We have seen in yesterday's class, no? mgh. And kinetic energy is half mv square. Here velocity is 0. See here, 0 meters per second, because it is at rest. So this v will be 0. So half mv square will be 0. That means kinetic energy will be 0 initial, and potential energy will be mgh. Okay, now when it is coming down, जब वो नीचे आ रहा है, so friction due the upside, friction force will constantly apply this force. Okay, and this constantly force is applied till distance 20. Okay, so I can say total energy initial will be equal to total energy final plus some is lost in friction, okay, plus work done by friction. Have you understood this equation? What I'm telling? This is initial condition. This is final condition. Okay, so initial ke paas, let's say it have 20 joules of energy. Let's say it lost 5 joules of energy in friction due to air when it is coming down. So I will write 20 is equal to 5, and the remaining 15 will be final energy. So same equation I have written. Initial energy I have, that is potential energy initial plus kinetic energy initial, is equal to total energy final is potential energy final plus kinetic energy final plus work done due to friction, that is force. Okay, और अपन को निकालना क्या, find the work done by air. So we have to find work done only, work done ही निकालना है. So directly I will write the work done due to friction. Okay, now potential energy initial we have mgh, kinetic energy initial we have 0. So potential energy initial is mgh, that is 5 into 10 into height is 20. Kinetic energy is 0. Potential energy final, mgh, here the potential energy final plus kinetic energy final will be there, total energy. So potential energy final is mgh. Height is 0. If height is 0, mgh is 0. So at this final position, potential energy is 0. But what is kinetic energy? Kinetic energy is half mv square. Half mass is how much? Mass is 5. Velocity is how much? 10 square. So it is basically 250 joules. That means final potential energy is 0. Final kinetic energy is 250. 250 सही है ना? 100 by 250, 5 into 5, 250. Okay. Plus work done. Right? So how much will be the work done? This is how much? 5 to the 10, 100 into 10,000 minus 250 I'll take here. That is 250 is equal to work done. Okay. Now there is a small change. What is the small change? Achha, first of all, let's find the work done. 750 joules. Okay. But this is not the answer. Can anyone tell me in the chat why this 750 is not the answer? Answer is minus 750. Can anyone tell me in the chat why 750 is not the answer? Answer is minus 750. It's very simple. Concept is very simple. Why 750 is not the answer, but minus 750 is the answer. Waiting. Anyone? Kuldeep, Darshini, Savi, Ram Prasad, Vinay. Because the work done is in opposite of force applied. Yes, correct. Sorin Chen. Basically, what happens here is, see the motion of the ball. Ball is coming down. Force due to air is up. Coming down, up. Coming down, up. Force is not in the direction of motion, but opposite to the direction of motion. That's why you have to pay attention on these things, okay? That's why the work done due to friction is negative of 750. Okay, so this is the answer. You can either do negative at the end, or you can initially do negative. Initially bhi kar sakte. You can write here minus ka WDF, but I'm not writing so that confusion is not there. ना इसीलिए मैंने बाद में किया है to explain this concept, right? Next, so let's come to work energy theorem. Basically, what happens? For example, if there is a block, definition we'll do later. There is a block. Okay. I applied a force on this block and this block started to move. Okay. I applied the force up to a distance of 10 meters. So here the block has reached. मैंने यहाँ तक force लगाया, right? I have applied the force up till here. Let's say it is 5 newtons. And then I'm not applying any force. Okay, this surface is frictionless. चिकना surface है. Frictionless or smooth. I applied the force 5 newtons till 10 meter distance. Then I released my hand. I lost some of my energy. Where that energy went? I have done some work. Where that work went? Anyone in the chat? वो work कहाँ गया? I applied force na on this block. This block started to move. I have done some work on this block. Somebody said na कि energy is conserved. You cannot create new energies, right? Mass to energy, energy to mass. This is the conversion. Energy can neither be created, or sorry, mass can neither be created nor be destroyed. So similarly, mass is analogous to energy also. If you have done some work, if you have done some energy, it will be converted into something else, but it will never be destroyed. Yes. So anyone, can you tell me where my energy went? Mera energy gaya kahan? Where my work went? Force is against the action. Correct. Lentinum. Participate. Don't sleep. Hitesh, Chandan, Anita. I have done some work on this block. That work is went where? Where it gone? No one. You have studied these topics, no? Yes, Sorichan. Answer is correct. The block has kinetic energy. So basically, when you pushed something, this block's velocity increases. Initially, the velocity was 0. Finally, it will have some velocity. If it has some velocity, it got some kinetic energy. That means the work done is converted into kinetic energy. This is called work kinetic energy theorem. Okay. Similarly, if I take a block which is kept on ground and I took it to some height h, I have done some work. Where my work is stored? My work done against gravity is stored as potential energy. Okay. It is recorded already on YouTube. No problem. I can record the class on cloud also. Okay. Basically, that's why sometimes I don't record, or sometimes I forget the first class to record, to be true. Okay. Chalo. So I have started the recording, no problem. Okay. So work done is stored in the form of kinetic energy in the first case. In the second case, when block is kept to some height, I have to push the block up and I have to keep there. My work is stored in the form of gravitational potential energy. Okay, this is called work potential energy theorem. And if we sum up, I can write work done is equal to kinetic energy plus potential energy. This is called work energy theorem. If you do some work on a body, it may change its kinetic energy or it may change its potential energy. Okay, now let's come to the definition. The principle of work and kinetic energy. So this definition is specifically for kinetic energy. States that work done by the sum of all forces acting on the particle equals to the change in kinetic energy of the particle. Okay, chalo. Let's move to conservation of mechanical energy. Okay, what happens? I told you there are two types of forces. Okay, one is conservative and one is non-conservative. Conservative force में क्या होता है? These are path independent. You take by any path. For example, you kept this block on some height h. So you take this block by this path and keep it here, or you take directly, or you take down and then you bring up. Any path you take, the potential energy of the block will remain same at that height h, that is mgh. So it is path independent. So all these types of fields or conservative forces tells one common thing, that mechanical energy will be conserved. Okay, what is mechanical energy? Till now, mechanical energy is sum of potential energy plus kinetic energy. Later on, when we'll study rotational, it will be the sum of one more thing will be added here, which is called rotational energy. Okay, so now we are not considering this thing. So mechanical energy is potential energy plus kinetic energy. And what is conservation? Potential energy initial plus kinetic energy initial. We already have done a question on this, right? Is equal to potential energy final plus kinetic energy final. That means if potential energy increases of a body, the kinetic energy will decrease, but there will be a balance of both. Okay, they both when added will get the same total energy or mechanical energy. So this is conservation of mechanical energy. Okay, let's come to power. Takat. Okay, power in Hindi we call takat, right? So what in case of physics is power is work done upon time. Let's say you and your friend are climbing a hill. Okay, hill is at 37 degrees. You both are climbing the hill. Distance is constant. Let's say it is 50 meters. You both started climbing this hill. You reached, कौन कौन है यहाँ? You and your friend. You reached in, कितना स्पीड से भगा दें? यूसेन बोल्ट का रिकॉर्ड 9.8 मीटर्स पर, ठीक है. सो 50 नहीं, 12 seconds. You took 12 seconds to reach, and your friend took, he is a fan of Usain Bolt and he also runs very fast, right? So he took about 8 seconds to run 50 meters. कितना लिया? 8 seconds. You both have traveled the same distance. You both have traveled the same hill. You both have traveled the same height, but time is different. So who have used more energy? You or your friend? Can you tell me in the chat? Who have used more energy? You or your friend? Or the energy is same? किसने ज्यादा एनर्जी का यूज किया होगा? Of course, friend, because he took less time. So he has run very, very, very fast. Okay, है ना? That means friend ने क्या यूज ज्यादा किया है? He has used more energy. Friend has used more energy, and a person can use more energy when he has more power. When he has more power, basically that is power. Okay, power can be analogous to energy also, right? And in physics we call power as work done upon time. So lesser the time, because work done is same in this case. You are traveling on the same hill, work done is same, but time is less for your friend. If time is less, power is equal to work done upon time. If time is less, denominator is less, the whole value increases. That thing you know na? If denominator is decreased, the whole thing increases, right? So this whole thing increases means power increases. So this is the formula of power, simple formula, right? We can remember this. Work done upon time taken. Okay, right? Chalo. Let's move to a question, very simple. You have to try this question. I'll give you 1 minute, then I'll tell the answer. Go on. Sir, is there class occurring in Zoom? Yes, of course. This is a Zoom class only. Experimental science. This is a Zoom class streaming on YouTube, right? So if you are there in Avanti group, you can attend the class on Zoom also. Okay. When a conservative force does positive work on a body, what will happen? If you don't understand these type of questions, just take an example. You will get the answer. Okay, Purna. Let's see. Let's see. Okay, Savi. Any other answers? Okay, chalo, let's see the answers. Any YouTube wala give answer? Okay, okay, okay. Sorin Chen, Sangam, experimental science. Okay. So first of all, this is a multiple type of answer. Okay, multiple choices are there, right? Okay. Now it is telling when a conservative force, gravity, electrostatic force, magnetostatic force, okay, does a positive work on a body. Positive work. So positive work means in the direction of force, the motion is there. जिस डायरेक्शन में फोर्स है उसी डायरेक्शन में क्या है मोशन. Okay, so I can take one example of a body falling from some height. Okay, this body is falling from some height. So who is the conservative force here? The gravity, let's say mass is m, so gravity will pull with mg, and also the body is moving downwards. Okay, so there is a positive work. If the direction of force and the movement is same, the work done on that body by that force is positive. Okay, so I can see in this case the velocity will increase. तो क्या बढ़ेगा? Velocity will increase. Velocity बढ़ेगा. Okay, because speed will increase because force is in the same direction of motion. Just now we have studied in conservative force, when conservative force is applied, the total energy is constant. अच्छा वो नहीं लिखा है क्या? We have not written this thing. Okay, so you can write here it is constant. ये क्या होता है? Constant in conservative field. Okay, so if total energy is constant and if velocity is increasing, velocity will increase means kinetic energy is increasing, because kinetic energy is half mv square. If velocity increases, kinetic energy will increase. अगर kinetic energy increase होता है, then potential energy should decrease. Why? Because total energy is same. For example, total energy is 20 joules, and from here kinetic energy is 10, potential energy is 10. Combination होता है ना kinetic plus potential. Now kinetic energy is increased. Let's say it is now 12. So potential energy will decrease to 8 because sum should be 20. So what will be the answers? First of all, C will be the answer and B will be the answer. Its potential energy must decrease. I hope you understood. If you understood, give me a quick tick or thumbs up. Jaldi, fast. Pakka na? If there is doubt, you can ask me. Okay? Yep. Chalo. So this is another good question. Okay. Let's read the question, then we'll do it. Okay. So you don't have to do it. I'll explain. It is telling one end of a light rope is tied directly on the ceiling. We can see that a man of mass m, initially at rest on the ground, starts climbing the rope. So this man is climbing the rope. Okay. Overhand up to a height of L. So this was the rope. Okay. This is the end of the rope. The person started to climb from here. Okay. Like this. यहाँ से climb करना start किया and it goes to some height L. यहाँ तक climb कर गया. Let's say this is L. Okay. He has climbed up to here. From the time he starts at rest on the ground, so he was standing on the ground. Okay, this is the ground. To the time he's hanging at rest to a height of L. So up to height L, from this duration, how much work was done? That is asking. And by whom? By the rope. So rope ने कितना काम किया? How much work the rope has done when this person is climbing the rope? That you have to find. Okay. Okay, Savi, let's see. Okay, I hope you understood the question. There is a rope. The person is climbing the rope. So you have to find how much work is done by the rope. not by the man. Okay. So we simply know what is work done. Work done is force into displacement. That's it. But force and displacement should be in same direction. Or you can write FD cos theta. अब rope की बात हो रही है. Rope is doing some work. So let's find the force due to rope. This person is having a mass of m. So this person will be pulled by gravity by mg. There will be a tension in the rope like this, like this. So this tension will be mg. This tension will be mg, and tension is the force by which is applied on this person. Okay, mg से नीचे खींच रहा है, टेंशन से ऊपर खींच रहा है रोप. सो रोप का फोर्स कितना है? हाउ मच इज द फोर्स ऑफ द रोप? mg. अप कहाँ है? अप. फाइन. mg फोर्स कहाँ है? अप साइड. होल्ड फॉर अ सेकेंड. Okay. So force is upside, which is mg. Now, what is the displacement due to that force? So displacement किसका है? Man का, which is also up. So displacement is how much? L. L it has displaced na, which is also up. Up is 0. If theta is 0, cos 0 is 1. So I can directly write work done is equal to mg into L, which is mgl. Have you understood? Option B. Very simple. Looks very dangerous, but question is very simple. If you understood, take and thumbs up. You know how to do. Great. YouTube wala. Nice. Okay. So revise this question later on. Let's come to another good question. Okay. This question we will do together. Okay. You don't have to do. Listen. In this question, it is telling, consider a roller coaster with a circular loop. So this is roller coaster. Okay. A roller coaster car starts from rest from the top of a hill, which is 5 meters higher. So this is the top of the hill, this place. So car is kept here. Car कहाँ पे रखा है? यहाँ पे. Let me make a small car. Let me show you my drawing. Yeah, one tire is small. Okay, so car is kept here. Okay, 5 meter height per, right? It rolls down the hill and through the loop. So this car will roll down like this. So it will go like this, like this, like this. Okay, ऐसे जाएगा. Okay सभी, let's see. I also don't know the answer. Okay, so it will go like this. It rolls down the hill through the loop. What must be the radius of the loop? Loop B, so that the passengers of the car will feel at highest point if they have their normal weight. अच्छा, do you remember what is centripetal force? Centripetal force याद है किसी को? Do you remember centripetal force? Okay, Alok. Anyone else? Just raise your hand. You can raise your hand. There is a button called raise hand. Remember na centripetal force? उसी से हो पाएगा. If you don't remember, it will not happen. Centripetal force means when a body is rotating in a circle, the force experienced at the center is centripetal force, which is mv square by r. You know na? Very good. Okay, that's good. Just what happened? Okay, that is mv square by r. Yes, it's towards the center. Correct. Okay, so this question can be done. So it is asking what must be the radius of the loop to be so that the passengers of the car will feel at the highest point if they have their normal weight. So when passengers will be here, It is telling passengers should feel their normal weight. Passengers को क्या लगना चाहिए? Normal weight. Okay. So let us name the points A and B. I hope you understood the question. Car is going down, 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 down. It will come up, 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 up. So when it comes at the highest point, you have to tell the radius of this loop so that the passengers at this point B feel their normal weight. Okay. Chalo. So A point or B point नाम देते हैं. Okay. And since there is no external force acting apart from the centripetal force की वजह से there will be no work done. Okay. So we can use conservation of energy at A and B. Okay. So at A point पर height कितना है? Let's take this height as h. Okay. इसको h ले लेते हैं. So this height will be h minus 5. Okay. And that is 5. Okay. So the A point per potential energy, what I'm using by using conservation of energy at A and B. Potential is 0. No, potential is not 0. So potential energy, I will write potential energy at A plus kinetic energy is equal to potential energy at B plus kinetic energy at B. Yes, it is mgh. Correct, Alok. So potential energy at A is mgh. है ना? It is mgh. Kinetic energy at A, since this car is at rest, so half mv square, v is 0. So kinetic energy is 0. 0 is equal to, if I talk about potential energy at B, B point पर क्या potential energy होगा? It is mg. How much is the height? h minus 5. B point पर height is h minus 5. Yes, correct. Plus kinetic energy कितना होगा? Kinetic energy, let's say the velocity is v. इधर क्या मान लेते हैं? Let's say the velocity of the car is v. Okay, so it is half mv square. Half mv square. Okay, so mv square by 2. No. We are taking kinetic energy. Hello, we are not taking the force, the centripetal force. Hold for a second. There is some disturbance. Okay, so I opened the bracket mgh and minus 5 mg. This gets cancelled out. So from here you will get this common and cancel out. तो इधर से क्या आ जाएगा? V is equal to root 10g. That is the velocity at this point. अच्छा, velocity आ गया and let's say the normal force. Normal force कितना मान ले इसका? See, at this point I'm redrawing this diagram. So at this point, which is point B, there is some, due to surface की वजह से क्या लगेगा? Normal, which will be down because surface is up. Car उल्टा है. Okay, car is उल्टा, like this car is. Okay, like this car is उल्टा. Okay, so normal will be downwards because surface is up. Also mg will also be downwards. mg भी downwards लगेगा. Right? Please pay attention. If any link breaks in this question, you will never understand. Normal is down on this car. mg is also down. Okay. And what is up? ऊपर क्या लग रहा है? mv square. mv square by r. Okay. ऊपर क्या लग रहा है? mv square by r. So this car is not going up, not going down. We can balance it, right? Balance करते हैं. So balance is all upward force mv square by r. all downward force. Centrifugal, yes, correct, all downward force, okay, which is N plus mg. This is what? This is centripetal, and this is what? This is centrifugal. Centrifugal क्या होता है? Outwards. When a car take turns, you move outwards. That is centrifugal. But who is balancing your that centrifugal? Centripetal. So here centripetal is N plus mg. Centrifugal is mv square by r. Okay. Equal करते हैं. So from here N we will get as N नहीं. N कितना आएगा? mg. 2mg. Okay. So N is mg. Normal force कितना होगा? In question it is saying ना, if they have their normal weight. तो अगर normal weight होगा, that means N is equal to mg. Simple. Normal force will be mg for normal weight. भाई weight तभी तो normal होगा. Yes or no? mv square by r is equal to mg plus mg. Okay, how I wrote mg? N equals to mg because in question it is telling if they have their normal weight, means normal जो है that is weight mg. Okay, so m gets cancelled out. From here r is equal to v square upon 2g. What is v? 10g. V square is 10g because v is under root 10g. 2g 5 meters. So what will be the radius? 5 meters, which is option A. This question is very good question. Okay, please revise this question again. क्या करना है इसको? Revise. It will give you so many concepts. देखो कौन कौन सा concept आ गया. First of all, you got the concept of conservation of energy. Second, you got the concept of centrifugal and centripetal force, which is circular motion force. Third, you got the concept of FBD, free body diagram. Normal mg and mv square by r. Fourth, you got a concept of their normal weight. Normal weight means the normal is equal to weight. N is equal to mg. Okay, right? So this type of questions come in JEE Advanced. Okay, they do not come in JEE Mains and NEET. इतना लंबा नहीं आता है. They will give some sections. So I have done, or I have told you this question so that you can get all these concepts all together in one question. Okay, when we practice for higher level, then this exam level will be very simpler. Okay, next. Okay, I have not seen you too. Okay, Samsung, I'll just off my video. I forget that many times. Okay, sir, how N equals to mg? Listen. यही तो खेल है. N equals to mg. See this last line. If they had their normal weight, means the normal which is applied by the surface is nothing but weight. What? Normal that is applied by the surface is nothing but weight. So I have put N equals to mg. That the question is telling in the last line. Got it? Alok, do it one more time at home. You will get that concept very easily. Huh? If you don't get, you can ask me. Yes. Next, impulse. Impulse पे चलते हैं. What is impulse? So impulse का definition is very simple. Let's say you are playing cricket खेल रहे हो, and ball is coming at your bat, right? So this is your, let's say, bat. Okay, so ball came on this bat. Ball was coming like this. Okay, ball was coming like this with some velocity v. You hit the ball because ball was having velocity in this direction. You hit the ball and ball started going in this direction with some velocity v1. That means you changed the velocity. And how you changed? By applying force. You applied some force. In how much time? in a very short period of time, that is dt. बहुत छोटे से time में, because the contact of ball with the bat is with a very 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 short period of time. Okay, so when you multiply this force into this small time, you get impulse. Okay, force for a very short period of time is impulse. Okay, now if the time is increased, time को बढ़ा दो. Okay, so you have to integrate, because that impulse or that force which is applied in this time, you have to add at all the times. छोटे 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 टाइम पर इंटीग्रेट करना पड़ेगा. So what is impulse? Instantaneous. Instantaneous is f dot dt. But if you want the whole impulse, you have to integrate f dot dt from initial time to final time. Okay, or I can write time initial to time final. So with is written here also the same thing. This is called impulse. Okay, and if the force is constant, you can bring the force outside of this integration and you can write this as the impulse. I hope you understood. Let's do a question, then we will understand it more easily. Okay, see this question. This question, what is happening? By there is it is telling there is a force, very dangerous type of force, है ना? But I can understand a little bit. I में है, J में है, and K में है. Means it is a three-dimensional force. Force which is acting in three-dimensional. Okay. Over the time interval from time बराबर 1 to time बराबर 3 seconds. Okay. So this is the question, and it is asking impulse. So just now we have studied what is impulse. Integration of f dot dt from initial time to final time. Okay. Now, what is f? This is f. Let's put 3t square I cap plus, sorry, not plus, it is minus 2t minus 1 j cap plus 2 k cap. This is the force dot dt. Integration is from initial time. Initial time is 1 second. T equals to 1. Final time is 3 seconds. So t equals to 3. Now the task is just to integrate. क्या करना है इसको? सिर्फ integrate करना है, and you have to put the limits. That's it. Okay. देखो, integration will take one by one. Okay, so I'll just little bit I'll help. So it is 3t square I cap dt minus 2t minus 1 j cap dt. Okay, this j cap I cap, these are the directions, so they will not be integrated, right? Plus integration of t equals to 1 to t equals to 3 to k cap dot dt. We can integrate one by one, yes or no? So 3t square का integration 3 into t cube by 3. Limit is from 1 to 3. Okay, minus 2 t का integration is t square by 2, right? Minus t, limit is from 1 to 3, plus 2 का integration is 2t, limit is from 1 to 3. So if I put 3 and 1 in this first equation, 3 gets cancelled out. I'll get 3 cube minus 1 cube minus 2 gets cancelled out. So if I put 3 here, I'll get 3 square minus 3 minus 1 square minus 1. Okay, plus. Okay, this is just calculation. If you miss any calculation, you can do it later. Abhi sirf samjho. Okay, now you just understand what I am trying to do. I am trying to integrate this equation. Okay, so 2t cube 2 into 3 cube minus 1 cube. So when you solve this, 3 cube 9 9 9 9 9. Here it is I. Don't forget the I cap, j cap and k cap. Okay, ijk, right? So 9 minus 1, कुछ गड़बड़ किया है? Had I done some mistake? 27 minus 1 is 26. 26 I cap. 9 minus 3 minus 6 j cap, है ना? And this is 0, huh? This is 0. 3 3s are 27. 26 into 2. This is not cube. 3 minus 1 2 2 4. Okay. Plus 4 k cap. Okay. So this is the impulse. ये impulse होगा. Have you understood this vector product? जल्दी से बताओ. Tick or thumbs up quickly. Was it simple? So you just have to apply this formula. Okay. That's it. Very good. Chalo. Next. Yes. Asking something? Ask. I'm waiting. Don't worry. पूछो fast लेकिन. I have to complete more things. Let us also try the, yes, of course, you have to try the question. This is just for your reference, okay? Nothing? Okay. Chalo. So sometimes graph question bhi aa jata hai. Okay, graph question can also come. So what you have to do in graph is very simple task. I'll teach you how. Graph of force time, not graph, area of graph of force time gives impulse. Okay, very simple to remember. You know impulse is f dot dt, yes or no? So whenever you multiply, you will get area most of the times. That's why area. Similarly, there are so many analogies. For example, if you want displacement from velocity and time, if velocity time graph is given, their area will give you displacement. Why? Because they are in multiplication. Okay. Similarly, if I talk about acceleration time graph. So acceleration into time is what? Velocity. So acceleration time graph ka area will give you velocity. So what I'm trying to tell is, whenever two quantities are multiplied and you get the third quantity, that third quantity can be obtained by finding the area of this two quantities graph. I hope you got little bit, right? Chalo. So now let's come to the question. Now question becomes bacha question. Okay, what we will do here is, a one-dimensional force F varies with the time according to the graph. Calculate the impulse. So this is the graph given. You have to calculate impulse. I just told you impulse is the area of the force time graph. Okay, this is the remembering point, right? So impulse kaise aayega? Area. Now if I find for the first point, which is from t equals to 0 to t equals to 10, so t equals to 0 say t equals to 10 is this much. Yes or no? Now it is your choice how to find the area. Okay, very good Purna. अब आपका choice है कैसे area निकालना है. I will find separate. इसका area 10 into 5 rectangle ना. इसका area half, base is 10 minus 5. So this base is 5. Height is 10. So it is 25. और इसका area half, base is 5, height is 10 only. This downside it is 10 minus ka. So 10. It is also 25, but minus ka. Okay. Now we can find the area. Area तो आसानी से आएगा, right? 0 से 10. 0 से 10 मतलब this much. So it is very good. Nice. 50 plus 25. 75 is the impulse. What is the unit? Unit क्या होगा? Impulse is force into time. Force का unit is Newton. Time का unit is seconds. So unit is Newton seconds. Yes, very good, Savi Darshini. Nice. Okay, चलो. Second वाला. Can you find B from 10 to 15? How much it is? 10 से 15. 10 से 15. I'll just color with blue. This is 10 to 15. Ten say 15. It is written there. Very simple. Yes, very good, Savi. It is minus 25. Why minus, sir? Because it is downside. Okay. That means उधर क्या हुआ होगा? उल्टा impulse. Okay. So it is minus 25. If I come across the third one, that is total. It is asking. So total is 50 plus 25 minus 25. Cancel, cancel. 50 Newton second. Simple, na? Yes, correct. So I hope you understood. So what you have to remember, whenever two quantities are in multiplication, their graph area will be the quantity which you are getting when you multiply those two. Okay, ऐसे याद रखना. This is a simple remembering technique. Okay, now let's come to impulse momentum principle. This is the last topic that we are going to study. Then you will be free. थोड़ा सा ये पढ़ते हैं. I'll give you one homework question. Then you can go. Okay. So impulse momentum principle. What is impulse momentum principle? We just studied that impulse is this thing. Okay. Impulse किसको कहते हैं? Force dot time. Okay. Now if I come here, this was what? Impulse. Okay. And according to Newton's second law, न्यूटन का सेकंड लॉ क्या कहता है? चेंज इन मोमेंटम इज इक्वल टू इंपल्स. ऐसा मान सकते हैं. ओके, अकॉर्डिंग टू द इक्वेशन. दिस इक्वेशन वाज गिवन अंडर सेकंड लॉ ऑफ मोशन. ओके, न्यूटन सेकंड लॉ. एंड व्हेन यू डिफरेंशिएट मास इनटू वेलोसिटी, कीपिंग मास एज कांस्टेंट. मास को क्या करा? कांस्टेंट. इफ मास इज कांस्टेंट, मास विल कम आउट. ओके, सो हाउ वी विल राइट एफ डॉट डी टी. Oops, sorry, f vector dot dt is equal to, mass will come out because I am assuming mass is constant, m dot dv. And what is dv? Change in velocity. So if velocity has some initial and final value, so what is the change in velocity? V final minus V initial. Always remember what is change. This is what? Small change. And what is change? Change is always final minus initial, always, in every case. Okay, that's why I've written final velocity minus initial velocity. So force dot dt, which is impulse, is equal to mvf minus mvi. Okay, if I put integration sign, same equation which is written here. Okay, so what you have to remember from here is impulse. This you have to remember. Remember, impulse is change in momentum. What is impulse? Impulse is equal to change in momentum. अच्छा, momentum क्या होता है sir? You are talking about momentum from so much of time. Momentum means there is a truck. Okay, and there is a bicycle. Bicycle nahi. Let's take there is a car. Okay, both are moving with same velocity, 10 and 10. If I, not I, if somebody, some of you, no, not some of you, if somebody came in front of the truck and somebody came in front of the car, more damaged will be truck wala person. because truck is having a very large momentum. Okay, then car. So from there momentum came into existence. And momentum देखो, if mass is more, because truck mass is more than mass of car, है ना, mass of car is less, mass of truck is more. So momentum is directly proportional to mass. If you increase the mass, momentum will increase. Okay, also momentum is directly proportional to velocity. If you increase the velocity, momentum will increase. So momentum is directly equal to m into v. What is this p? Momentum. Okay, so this is the this is everything about momentum, right? So change in momentum is impulse. Okay, chalo. So this question is for your homework. This question can be easily done with the definition which I have told you of moment of impulse. Okay, is everything fine? Sab badhiya? Take the screenshot of this question. तो आज के लिए यहीं तक की कहानी है. If any doubt is there, you can ask me. Otherwise, please complete NPS and go. How to submit homework? You don't have to submit the homework. I'll discuss the question in the class. Okay, tomorrow there will be class, na? So you just come, tell me the answer, check your answer, I'll tell the solution. Okay, thanks for completing NPS. We will meet tomorrow. Okay, please do this homework question and come. We will tomorrow see more topics of, I'll just explain you a little bit about gravitation also and rotation. Rotation, I think moment of inertia is very important to revise, है ना? And center of mass also. So we will play along these topics and we'll do some questions. Thank you all. Bye bye. Take care and have an awesome day. Bye bye. Okay, Sabi. Bye bye bye. Okay, Alok.